Ladies and gentlemen, this is Joe's Classic Video Games, back with another cool jukebox repair video for you today. We are looking at a beautiful Rock Ola Super Sound 2 496 jukebox, Rock Ola 496. Now, Joe has went and picked this up today. Joe, tell us the story behind this jukebox.
We sold it to a guy 7-8 years ago, and he had another one just like it, actually. I guess he just likes this style box. And anyway, he's moving, so he sold them both to me today. So I went and got them.
So both of them are not working. The other one hasn't worked in quite a while, and this one stopped working recently. We sold him this box, so we had it up and running and everything, but I don't know how much stuff we had worked on before, or if we just bought it and it was working. But it's doing a particularly strange thing right now. Now, this was at a weird time in Rock Ola's history. They were starting to design these new CPU boards to run the machines. So the 480, the 484, and maybe a couple other ones had a certain type of CPU, and then the 490 and 494 had a different type of MPU. I think that may have been in the 488 as well. I can't remember. And then this is a 496. Well, they were just getting started making CD boxes, or maybe the next box was the CD box or something like that. So they have this CPU here that you only find in a couple boxes, but it's very similar or the exact same one that's in the early CD boxes. So this one has a kind of weird fault that we're going to show you, and then we're going to see if we can fix it. And so if you experience this fault in your machine, maybe you can fix it in yours. These Rock Olas are kind of interesting to work on, and I like kind of messing with them. So we'll see what's going on. All right, Joe, so what's it doing?
It keeps playing the same record over and over again.
Okay.
And it's stuttering. It keeps cutting on and off, kind of jittery.
Okay, cool. All right, so he's going to turn it on and show you what it's doing. So see how it stopped? It's stopping. Cancel it. So see how it's stopping? Now listen over here. Okay, Joe, that's enough.
These lights were all jittery too, but I unplugged them.
Okay. Oh, and also the light on the CPU is also doing it. All right, Joe. We've heard all we need to hear. Okay, so you're hearing down here in the bottom like a ticking, tick, 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 tick. That sounds like that same freaking relay that we messed with in the 494 that we were messing, or the 490 that we were messing with, Joe. So it looks to me like what's happening is the power is coming on and off, on and off, on and off, and I don't think that it's the power to the MPU. That light blinking, I think, is just residual power, since the power's spiking, turning on and off for the mech and stuff. I think it's just making that light blink because the CPU keeps playing. But it may be screwing up the memory in the CPU, which would explain why it's playing the same song over and over again. So we got that going on. And then the turntable is way too slow, but again, I think that's because it's turning it on and off, on and off, on and off, and it's slowing it down. So instead of being 45 speed, it's like 30 speed or something like that, and it just sounds real weird. So I think our problem's going to be down here in the power supply. How y'all doing today? Good. I think the power supply is going to be our problem. So I'm going to look at the schematics and see if we can figure it out, and then we'll pull that out and work on it a little bit. All right, folks. So we have removed the amplifier. I'm not the amplifier, the power supply. It literally plugs straight into the wall. This is where the line comes in, and this is the actual power switch on the back of the machine. Now, this era of Rock Ola, 488, or let's say starting from the 480, 484, 488, 490. There's three different versions of the 490. The 490-1, the 490-2, the 490-3. There's a 494. This is a 496. There's also a 498. There's a bunch of them. So there was about 5 or 6 years there that they were running kind of the ones that were their first computer-controlled ones, right? And depending on which box you have, the power supply will be different. There's 3 or 4 different brand models or part numbers. The CPU will be different. There's just differences, okay? So this one is the Rock Ola Power Distribution 55135-A. I do not have schematics for it. I thought I did. I had a viewer who was kind enough to send me a whole bunch of them, but we didn't have these, unfortunately. So I've got the ones for 490 that say they're for 496, but they don't have this power supply in it. It's got the old one. Here, I'll show you. 490, 496, 498, 1000. Some of the stuff is the same, but the power supply is completely different. So I don't have a schematic. We're just going to have to try to figure it out. Now, if you look on the front, they did a really good job of labeling everything. So the CPU board runs not on 5 volts, but 5.7 volts, believe it or not. Okay, so there is a line that it wants to be as close to 5.7 as possible. Also 26 volts, I believe that's the voltage that runs the mechanism and stuff. But there's also on the power supply before this one that we did a video on, there was a switched voltage that turns on the turntable and also turns on the mechanism. So, look, mechanism plug, and there's a card edge connector. Completely different from the last power supply that we did. You also have a connector for the bill acceptor, connector for a CD player. Right? So they were just at the time when they were letting those be added into the 45 boxes. Connector for lighting, and a connector for the amplifier. So when you're trying to figure out what's going on, our amplifier was working fine, the lighting was working fine, bill acceptor we don't know about or care about. We don't have a CD player. So we're interested in this turntable connection and also this mechanism connection. Okay, so this lid on this particular model is just hinged. And you can see on the lid, all that you've got are the connectors, which is a pretty good way to do it. Okay. They all are in nice shape, look good to me. You know, we might spray a little contact cleaner on them. And so here is what's on the bottom of those regulators. Now, I don't believe those were the problem because the thing was working, it was just turning itself on and off. That may be a, I don't know if that's a Mylar cap. If it is, I'll probably replace it. Mylar capacitors have a tendency to short, and so it could be shorting and opening back up. Okay, so here's the big transformer. You have a, you're looking at the power switch from the back of the machine that we were just looking at, and here's where the line voltage comes in. Okay, so here is a fuse that mounts externally. That's going to be probably your main line fuse. Yeah, so you see the black line coming into through the fuse, and then the brown line coming back out to the switch, and it is switched, okay? This here is just like a junction where a bunch of ground wires run together. And then you have a line filter. Well, none of that's going to be our problem. Okay, but that's the main power source coming in. And then the power supply actually consists of just this little board here. The rectifier PCB. And you're getting all your voltages that you need from that. But here's our problem. On the previous video that we did on these, we did one where we rebuilt the power supply in a Rock Ola 490. It's very similar to this. It had a different connector, but the board was basically doing the same thing. You have a few fuses here. Few fuses. When have you ever heard somebody say that? And you've got a couple filter capacitors. But look at this. This is a optocoupler. So this optocoupler is what actually turns on the turntable. On our previous one, we had the same problem where the turntable wouldn't work right, and the mechanism, the power wasn't there. So that optocoupler is turned on by a signal from the CPU that I suppose would come in here. and then that same signal turns on this relay. Now this relay is some rare freaking relay that you can't get. So on the other one, I had to wire that sucker up with a new relay. But I think this thing is a problem often. But we're getting a little bit of a different situation here. The relay is turning on and off, on and off, on and off. So the relay is actually working. That's why we're getting the power. But then it stops and stutters, which means that the signal running it, or the signal coming from the CPU and running the optocoupler, remember they're both doing it, right? So both of them are screwing up. So we're in a situation where it's probably actually the signal from the CPU that's the problem. That's why the turntable is slowing down and the mechanism is slowing down. The same signal runs it. Let me show you on the schematics for the 490 so you can get an idea of what I'm talking about. It's a real simple little circuit. So here are the schematics. This is from the 490-1. Now there's a 490-2. And then the 496. So they have different power supplies. There's 2 or 3 different power supplies. But these are the schematics that we're interested in. Now, if you look over here, there is a signal. Let me find it. This run signal. Right? And it has a line over it. So I believe that means, well, I don't know what I want to. I think that means that whenever there is a signal, it doesn't run. So basically, whenever that's grounded, it's going to run. So the gray and black line that comes in, okay? Now, it's going to be different on this one, but it's going to be the same idea. There'll be a line coming from the CPU, okay? And what it does is it turns on this optocoupler, okay? When the optocoupler turns on, you're basically using, low voltage to turn on AC voltage. So this optocoupler chip turns on what they're calling switched 120. Okay, the switched 120 goes out and is the power that runs the turntable. Okay, so that's running slow on ours. So it could be the optocoupler, but since we also have the mechanism starting and stopping, I think what's happening is this run line is starting and stopping. So it could be something connected to the run line. Maybe this is starting to short and so it's doing it. Or maybe down here is starting to short so it's doing it. But it could be something connected to the line, or it could just be a bad connection on the thing. Okay, so that same line runs through this resistor, R2. Okay. Comes down here and turns on the coil. The coil turns on the relay. The coil is in the relay. Turns on the relay. Now, they've got it where the 24 volts is shorted to ground by the relay. If the relay turns on, now this heads over here, makes some other stuff happen. But because that's no longer shorted, this diode is allowed to do its thing, and it creates 24 volts, right? And that blah, 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 and is turned into 26 volts. So, what's the problem? It could be, if you look on this, what I would see jumping out is, look at this capacitor. It's a 10 microfarad, 35 volt, and it's probably a tantalum. Those short, so it could be that cap is starting to screw up, and it's causing us problems on that line. So that would be one of the first things I would check. Now, this setup here looks like it's a little bit different, but it's the same general idea. There's something going on with that line that is making the 120 stop working and the switched 26 volts stop working. Not to be confused with the 26 volts. It's the switched 26 volts. So I got to be very careful, since I don't have the schematics, and not unplug all of these lines, because I won't be able to plug them back in. So what I'm going to do is very carefully lift that up out of there, clean connections, swap capacitors, etc., and we'll see what that does. Okay, so I've replaced this tantalum that was here, and then we replaced the 2 large filter caps. Now, if you look real close, we don't have the schematics. We're just trying to figure it out. If it's set up the same as the other one, there is a line coming in here. I'm just guessing because of its routing. And then it does go under this relay, so I can't see it completely. But if you look, it looks like maybe it's that little So if you look at the routing, this one looks like probably goes to pins, these 2 join pins. And then this other one goes under here and stops somewhere, right? Well, it kind of looks like maybe it goes to there. See, that's a via where it goes through the board. And then one side goes over to here, which is a resistor connecting from here to here. These are the 2 terminals on the coil on the relay. So that a resistor connects it to that little via, which I think connects it to this pin, which would be the signal coming from the computer. And then that same line comes up here to a diode, and then through the diode, and this is the optocoupler. Okay, so that line, it appears, comes in on that pin. So if that was making a bad connection, you would get the problem that we're facing. So connection problem or what? I'm also going to replace the diode. So it's this diode right here, CR17. So I'm going to replace that one just in case there's something strange going on there. And then we're going to put it back in. It could be the old diodes here, but we're going to wait on those for now. Okay, folks, so at the same time, from the same gentleman, we actually got a second one of these machines that we're also going to fix. I've actually completely removed the board from this one because it had much more severe problems than the other one. So I figured I'd film this just to show you, in case you do have to take the board out, how the wires hook up. So this is what they have numbered pin 6 on the PCB. It's the blue wire. Pin 5 is the black wire. Pin 4 is the blue and red wire, blue wire with a red trace. Pin 3 is the green with yellow wire, green with yellow trace. And then pin 2 is green with a white trace, and pin 1 is also green with a white trace. Those 2 you can reverse because it's an AC voltage. Excuse me, some of the other ones probably are too, but those 2, you don't have to know which green with white goes where, right? But they're pins 1 and 2. So the reason I have taken this out is this board is destroyed. Look at this. I don't know how common this is, but if this happens a lot, this might be a good candidate for someone to reproduce the board. So what happened was, this old cap finally gave up the ghost. 2200, 63 volt. Right, and then this one over here is a 4700 35 volt. So when that happened, it burnt the side of the relay. I guess because maybe that's a diode. I might have to look back on the other board. Looks like that's a diode. So this thing, pretty rough. So I'm gonna pull these parts and clean that up and see if I can make sure that the carbon on the board isn't going to short a couple traces together. And then we'll see if we can put it back together. So here's the back. You can see it's gotten hot where that, I believe that's a diode is. And then you can see when the capacitor, which was here, shorted, you really started getting some heat here on the board. Most of that doesn't connect to anything though. Well, I guess it goes to the two diodes. It almost looks like someone has repaired this before. See the little pin connecting to the 2 diodes? Why would they do that? It's because this trace back here was screwed up. So that's an old repair. But this is what killed us here. Okay, so I'm going to clean this up as best I can, and then I've had to actually order some more relays. I ordered some bigger ones, but we'll do the same with it. We'll do the remote wiring and all of that, and see if we can get 2 machines up and running. Ugh. That could be just the juice leaked out of the capacitor. It could be capacitance juice. Could be, but I don't know, man. It's all over everything. Kind of looks like somebody may have spilled a soda pop. Might be soda pop. But, yeah, wow. Yeah, I think this over here may have been an earlier repair. This is the new failure. So this is after cleaning it off a little bit. You can see the charred area there. Whenever the board burns, it becomes carbonized, which means that sometimes it can conduct. So you got to be careful, because if you leave the trace running over the top of that, you need to measure to see if that's carbonized enough where it will conduct electricity between that trace and the next trace, causing a short on your board. But the way this thing is designed, if you look, pin 2 here, that trace came loose. See the track that's missing? I just cut the extra off. But pin 2 here, well, it's actually pin 4. But the second pin from the top that you can see would have swooped around and connected to this fuse. So I can add a jumper wire to replace the trace. And then pin 3, or the third one that you can see, let me show you with the file here. This one goes along here, and then it hits a via, goes to the bottom of the board, and comes over to here, and then comes back up through the board. And then also, if you look real close at the third one, see the little round via there, there, and there. What that's doing is those 3 are connected on the back as well. Right, there, there, and there. So both sides are the same on those 3 pins. Okay. So what that means is we can lose those 3 traces pretty easily. The ones that are in the majority of the carbon, cut the traces, and then run a jumper to where they were going. Pretty easily, and that basically we won't be using that part of the board. Okay, there was that diode there, so we'll have to look at that. But again, worst case scenario, it connects to here, and then needs to connect way up to there, to these. So you could, there's things you could do to get it out of that carbon area. And the best thing to do would be to remake the whole board, but nobody's done that yet. Okay, so let me work on a little bit more, and we'll see how nice we can get it. Okay, folks, so this is what I came up with. So the cap down here we replaced with a new one. It's a 4700 UF 40 volt. The 4 rectifier diodes over here were fine, but they were so old and they were obviously putting off so much heat. They were 2 amps, so I replaced them with some big old honking 6 amps. Which I just happen to have a whole ton of, so I put them on everything, just like that hot sauce that they do the commercials about. These ones down here look fine to me, and they're not overheating or anything. This little chip is the one that controls the. It's an optocoupler that controls the turntable, turns it on and off. The 2 fuses were blown, F3 and F4. Okay, probably because of one of these fires. Those 2 rectifier diodes that were there also replaced, just because they look like they'd been through it. Okay, I checked all of this for carbon. I mean, there's obviously carbon, but I checked for conductivity. Nothing is connected to each other, even though it looks like it's burnt all to crap. So, hopefully we'll get away with it. This resistor here was looking pretty bad. It's a 4.7 K ohm. 4700 ohm resistor, half watt, replaced it. It was fine before, but it just looked bad. This resistor was fine. The tantalum capacitor replaced with a electrolytic. The big capacitor here was a 2200 microfarad. I mean, I said that wrong. 2200 UF 63 volt. So got a new one of those in, swapped it in. That was the bad one. That was the one that was leaking and probably caused all of the problems, right? And then there's a little diode down here too, which is just a little 1N4002. Went ahead and swapped it with a new one. It was all charred looking. And the relay. Okay. Now the actual traces that ran over that carbonized part of the board, I just removed and put wire jumpers, so that basically there's no two traces running over that carbon that could short together through the carbon. I cleaned it up as best I could, but it's still burnt, you know, so it still could conduct. But all of those traces aren't doing anything that go anywhere near there, with the exception of those two that obviously have the diode on them, but they're not connected. So I put 2 traces on the back and 2 traces on the front, removed the 4 traces that ran across the board in that area, just so they wouldn't short together, but they were not shorted together, okay? And then did the trick that I've done on a couple of these other boards, now, a couple of these boards already now. Take a different relay and take it up off the board and wire it in with wires that go to the correct locations. You have to do that because you can't get this original relay anymore. This is the original part number. Okay, this thing, people are wanting a freaking fortune for it. As you can see, this one's seen better days. So these 2 outside terminals are the coil that turns on the relay. This is the common for the contacts. And then this inside one is the, let me make sure I got it right. This inside one is the normally open, and the outside one is the normally closed. Okay, so you can look up the part sheet on it. So I just put wires on another relay and ran them down to where they go. Okay, you have to make sure though that little stuff like this doesn't short out on your frame. So I'm going to see if I can attach it somewhere where it won't jump around. Maybe something like that. What do you think? Now, people, if that would short, then that would short. I mean, come on, look, see, you see how this something could touch that. You don't want anything to touch that, but it could. If you're worried about that, you should be worried about. Come on, people, come on now, it'll be all right. All right, so we're gonna pop it back in, and then I'm gonna plug it in, and I hope I don't kill myself, and check voltages. Here we go. Okay, folks, so we're checking all of our voltages. So the first one and the easiest one. Got a ground on the frame here, is our 24 volt AC. Now these are the wrong schematics because I can't find the schematics for a 496. And before you say, oh, I've got the schematics for the 496, do you really? Because I've had 3 people send me the schematics for a 496, and all 3 times they were actually for the 490. So we got to find those schematics, people, one of these days. Okay, so they're hard to find. Okay, but this one is an easy one to check. So I've got my meter on AC. I'm just going to check it on the actual fuse, right? And again, these are wrong schematics, but it's pretty much the same, right? So if I check on the fuse, I have 26 volts. So our AC is there. The problem is the connector that goes to the mechanism is different. It uses the edge connector down here. So that's a little harder to figure out. But one that I have tracked down is the one that we're using this relay for. So this relay turns on and it removes the short across this diode that is shorting this 24 volts to 0. It's actually on mine, it's shorting it to about 2 volts. Whenever the relay pulls in, this opens up, which allows the diode to allow that voltage to rise to 24 volts, right? So right now, we are at, let me see if I can do it carefully, 2.7 volts. So I'm measuring this line, right? I'm actually measuring this line. This switched to 26 volts. So I'm measuring this line. It's at 2.6 volts right now. Okay? Now, if I ground, there's a resistor right here. I guess I should show you that. I don't know if I spoke about that earlier. Essentially, the CPU sends this run line low coming from the CPU. It comes over, it turns this low, which through this resistor turns on the relay. Turns on, that's this line. It grounds this, which turns on the relay, which removes that short, which allows it to go high. Right? So we just checked it, it's at 2 volts. So I'm going to simulate the ground condition from the CPU. Okay, so I've attached the an alligator clip to the resistor. Now, if you listen real close, you'll hear that new relay turn on. I'll just touch it. To hear it, you can barely hear it. Right. So if I attach an alligator clip to ground, now when I check that voltage, very carefully, I have our switch 25 volts. Yeah, very cool. Okay. So we've got that. Our 5.7 is right here. Let's check that. Got 6.25. Yeah, baby. It's looking good. Everything seems good. There is a negative 28 volts. I'm not sure if we have that or not. Let me see if I can find that one. It's on a violet and yellow wire on the other machine. So let me see if I can find the negative 28. Okay, so the negative 28 was created from this area, which, as you can see, comes from F2 originally. It's a negative 32 volts, and they do some things. But if you look on this rectifier board, there is no F2. So they must have decided that they didn't like the negative 28, so it's not an issue on this machine. Okay, we've checked our 5.7. The 12 volts is also there. It's 14.4 right now. The only one that we have left is this switched voltage here for the turntable. So there's a neutral, and this is an optocoupler here that turns on the 120 for the turntable. So you can turn the turntable on and off depending on if the computer has sent this run line low, which we're simulating with our alligator clip. Okay, so I should have between the white wire, which is neutral, and the red and green wire, a 120 that switches on and off. Okay, folks, so the switched 120 seem to be just fine. I'm going to show you that this is that same board mounted in there. Notice the charred part. Okay. And we've got it mounted back in this machine here that we're working on. And let me see if I can get a record to play. Let me turn down the volume so YouTube doesn't give me the copyright strike. So you'll just have to imagine what's playing. What's your favorite song? That's the same one I just picked. So notice that the turntable is spinning as the box is spinning. Lays it down, lays it over. Everything's cool. It's working as it should. What song is that? Oh, it's... Y'all ready for this? So everything's cool. We'll hang it up. So that's just a little idea of what to do if your power supply on a... It's the later 490 models and it's the 496 models. This is actually a 496 here. But if you've got that power supply or one like it, that's what you need to look at to repair yours. I hope this helped you and I hope you found it interesting. We really like these Rock Olas, and the more we work on them, the more we understand it. It's really a pretty decent little system the way it was designed. It's got some little idiosyncrasies, but notice that I was able to get a part and replace it even though the board had been horribly damaged. So leave your comments below. Let us know what you think so far. What do you think, Joe?
It's great. I love it.
Joe said it's great. He loves it. All right. Leave your comments down below. Make sure to give us a thumbs up for taking the trouble to film it for you. And make sure to check out our website. Go to lionsarcade.com. We have a parts page on our website with a lot of parts that we use in our videos. Just generic stuff, though. We don't have any Rock Ola parts, but things like oil that we use on the mechs and things like that are listed on our website. There's links to Amazon on there, some of those products. And then if you click those, anything you buy on Amazon gives us a tip. So we appreciate everybody that's been doing that. And last but not least, don't forget to check out my brother Donnie. Our brother has his own channel here on YouTube where we work on jukeboxes, arcade games, pinball machines, stuff like that. But Donnie works on buildings, cars, things like that. I'm over there with him a lot. We will see you on the next video. We're going to do some more videos on this Rock Ola 496 here, so stay tuned for those.